Hi, Assalamualaikum. My name is Siti Kamarina Liana binti Muhammad Zin with metric number S59667. Let me introduce Monte Carlo method as the opening of presentation. Monte Carlo method is a mathematical methodology that creates random variables to describe the risk or uncertainty of a specific system. It is one of the well-known methodological problems as a statistical analysis based on repeatedly replicating a chance process and directly calculating the values of crucial parameters.
Hi, my name is Siti Asnalina binti Abdul Rahman, metric number S59192. I will explain about financial assets. Financial assets are assets that result from contractual agreements on future cash flow or from owning equity instrument of another firm. There are several types of financial assets. The following is the classification of the fundamental securities. Firstly, bond. Bonds are fixed income securities that represent loans made by investors to borrowers, typically business or government. Next, stock represent part of the owner's capital in a business. Shareholders are the owners of the business and share in the success or failure of the business. Last, derivative. Derivatives are financial assets whose value is derived from another underlying asset. This is essentially a contract.
Assalamualaikum. I am Wan Anis Shakira binti Wan Mazlan with the matrix number S60184. I want to explain about income securities, or usually we call it as fixed income securities. Fixed income securities is an interest of asset that has the fixed value of payment by the holders, investors, or any entities and own a return eventually on its maturity time. This means that for a certain period that investors had invested, or we call it as maturity time, the investors will get back the return or the initial value, or we call it as a face value, on its maturity time. There are many types of income securities, but the three main types of fixed income securities are the corporate bonds, the municipal bonds, and the treasury bonds. There is another popular bonds which we call it as high yield bonds in investment, but it is not recommended for investors to invest in it because it has higher risk in investment, which will come to default and leads to bankruptcy. The corporate bonds are usually for a long-term investment for at least 1 year of maturity. Its benefit is the investor will get the pre-established payment whether at a fixed or different rate. The municipal bonds are usually invested by certain organizations such as government for public facilities such as roads, airports, or schools. Lastly is the treasury bonds. Treasury bonds are the most popular bonds among the investors as the maturity time is up to 20 years. The treasury bonds are issued by United States government and its debt securities are issued by federal government. But although we have these three different types of fixed income securities, the way of bonds react is same, which is when the bonds meets its maturity time, the issuers will repay the par value or face value to the investor on its maturity time. Commonly, the market price of bonds are different over the time. When the price is above the face value, the bond will trade at a premium, while when the price is below the face value, the bond will trade at a discount. But the price will constant with the par value or face value on its maturity time. At this point, the investors will get 100% of the return or the initial amount that they had invested if it doesn't come to default or if the investors continue to invest.
Next, we move to modeling the dynamic of asset price. First, from discrete time to continuous time. Discrete time and continuous time are two distinct frameworks for modeling variables that vary throughout time. Then, by using the continuous time stochastic process, the solution is not obvious when the winner process serves as the fundamental unit. One limitation of stochastic differential is that the chain rules cannot be used. Therefore, itu lemma determines the differential of a stochastic process time-dependent. To find the interest rate modeling, a generalization of geometric Brownian motion is constructed, and that is how to model the dynamics of asset price.
Hi, Assalamualaikum, and my name is Nuratika binti Ismail. Now I will explain about the example 1. In order to compute the stochastic integral of W squared T, we may simply apply Ito lemma to the case xt is equal to Wt. By setting alpha xt is equal to 0, bxt is equal to 1, and fxt is equal to x squared t. So, fxt is equal to x squared t, we need partially derive it with respect to the time is 0. Is it true that fxt t depends on the time through xt? But here, we have no direct dependence of t. Thus, the partial derivative with respect to the time vanish. Okay, so Ito lemma tells us that df is equal to dw squared. So, dw squared is equal to dt plus 2w dw. It is instructive to note that dt is term which we will not expect by applying a usual chain rule, but this term allows us to get the correct expected value of w squared t, since w squared t is equal to w squared 0 plus integral 0 to t dw squared t is equal to 0, and etc. So we can take in that expected value of t is equal to t. So Ito lemma may be used to find the solution of stochastic differential equation. At least it relatively simple cases. A most important one is geometric Brownian motion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Navara Waida binti Abdul Ghaffar. I will continue to explain example 2, which apply the geometric Brownian motion. The geometric Brownian motion is defined as dst is equal to mu st times dt plus sigma st times dwt, where sigma is referred to drift and mu is referred to volatility are constants. Then the expression can be written as dst per st is equal to mu dt times sigma dwt. Next, to apply the Ito's lemma, we need to compute the partial derivative first, as you can see it in the equation C. Then we may write as the equation in D. So the answer we will get dy is equal to mu minus sigma square per 2 times dt plus sigma times dw. For distribution, Wt can be written as Wt is equal to epsilon squared t, where epsilon is n01. The logarithm price is normally distributed as shown in the equation E. Then the solution in terms of st is shown in equation F. To the geometric Brownian motion model, the prices are log normally distributed. The relationship between normal and log normal variables can be concluded in equation G, where the mu is referred to the return of continuously compounded and the sigma is the standard of deviation of the increment of logarithm price. Next is the approximation of equation characterizing Brownian motion that also can help one understand the function of drift and volatility, that shows in equation H, where delta S per S is the return of asset over the small time interval delta t. According to the model, this is normal distribution, just a local approximation of the true log normal distribution.
In Test B, sales offer from a wholesaler is the Monte Carlo simulation example that we find in a journal article named as Assess Probabilities of Various Business Outcomes. This company makes some assumptions to project the future production and revenues. These are the assumptions, but then there is an issue. Would you accept a wholesaler's million offer to purchase your entire year's worth of output and inventory, which would prevent you from selling anything else? The journal states that in order to generate random scenarios, we must first develop data. This is done in order to comprehend the likelihood of reaching certain outcomes. Let's say we have 10 possible outcomes and we see that 5 of them achieve sales that were more than 6 million offers, but it is no guarantee. So, we have to look out the average sales we would expect if we don't accept the wholesaler's deal and the probability of selling more than 6 million as the offered deal. So we run the programming in Python software and get the result as this. Now we can see that making more than 6 million in sales is merely 36%. By taking the average of 10,000 scenarios, we anticipate selling 5.45 million worth of goods. This contract not only eliminates unexpected sales but also represents an excellent value. You will benefit from knowing that the Monte Carlo simulations indicate only a 5.9% chance of achieving it. As the conclusion, the implementation of Monte Carlo would be more involved in many real-world application scenarios, especially when dealing with correlations. Numerous other applications can leverage the versatility of Monte Carlo simulations. We hope many people will understand how to apply this strategy, particularly in finance. Thank you for your attention.